Another test design approach, syntax diagrams, or what a lot of people these days seem to call railroad diagrams. Syntax diagrams have been around actually for a long time. I learned the Pascal programming language somewhere around 1979, and the book that I had to study Pascal was by Jensen and Werth, and it was one of the beautiful structured programming languages designed to teach programming to people. And in Pascal, it was described completely with a series of syntax diagrams. And so we learned Pascal through syntax diagrams. Syntax is something that is part of construction of strings that have certain meaning. For example, your Medicare card has a social insurance number in it. It has a Canadian, what can I say, a registration number in it, which follows a specific syntax with letters, numbers buried in there's your birth date somehow. Your driver's license number has a certain syntax, depending on where you're from. There's different IDs that have different syntaxes. There's also something that you use a lot today, your email address. That has a syntax. When you use a programming method like payloads in microservice architecture, stored as XML, there's a syntax for XML, or stored as JSON, there's a syntax for JSON. Every programming language has a syntax. A lot of data organizations have syntaxes. And so when we receive something, it's sometimes a healthy thing to be able to judge, do we have something that complies with what the rules of syntax are? So this is something, as I say, more and more, I'm going into organizations that are not familiar with syntax diagram testing, and they end up trying to figure out test design for problems that would be a natural solution if you had a syntax diagram. So I'll share with you some examples of that. But the classic I'm seeing today is people testing email parsers. So they're really they're receiving an email, they're parsing it, and they're manipulating it. And it's as if that for the first time in the history of computing, teams are basically inventing their own email parsers. And these companies doing this are among the biggest, very successful companies in the world. So I'm not just talking about small mom and pop shops here. There's a lot of people who are doing syntax parsing today and have no idea about syntax diagram testing. So I urge you, if you run into a problem which sounds like you've got to make things which conform to a syntax, just say something like this: hey, we've got to make sure our payload conforms to JSON. Well, how do you check, is it in a valid JSON syntax? Of course, you might use a third-party object to help you do that, but the way that it's designed is usually with a syntax diagram or a railroad diagram somewhere along the way. Syntax validation today is found in parsers, maybe regex pattern matchers, formatters, XML, JSON, and in static analyzers. We see syntax is something that basically are rules to suggest that a stream of data has a certain integrity and is meaningful to us and can be interpreted meaningfully. In fact, if you look at coding and error coding, that's all done with syntax diagrams. So basically, the syntax diagram, to create one, you have to understand the syntax rules. You then use circles to contain the objects of your syntax rules, and you use arrows to indicate the order, thus creating a syntax diagram. The syntax diagram can be used, by the way, as an automata, and it is very similar to a state model and is drawn as a directed graph. So if you have a syntax diagram, you may be suggesting that some interesting tests would be following, for example, a path analysis. Try all nodes at least once. Try all basis paths at least once. Try all edges at least once. These are interesting tests from syntax diagrams. So as we say, we exercise the valid paths, but then we might try to violate the syntax and exercise invalid paths. Try to create objects that do not comply to syntax and see how your application behaves. Out of sequence operations, invalid, unexpected operations, or have multiple threads mucking with your syntax at the same time. This is an interesting thing where your syntax automaton may be moving through different objects at the same time. The example that I want to share with you here is a fairly straightforward syntax diagram that's used to understand how a number can be parsed in JSON. So imagine, and this is done with a beautiful tool. It's a free tool called Syntrax, which is basically designed to help you build what they call railroad diagrams or syntax diagrams. And they have a beautiful language, a specification language to define it. It's all done with Python. And the output that they give you is in one of many formats. For example, vector graphics formats or PDF files or PNG files, things like that. So we have basically this image comes out of the tool. This is the syntax for putting it in. It's a very text description of what is the rules. So you'll see this, there's a starting point, there's an ending point, and you'll see at the beginning here, it says, aha, okay, the first symbol can be nothing or it can be a negative sign. So we're looking at numbered syntax in JSON. So nothing or a negative sign. Then it's followed by a 0 or a number from 1 to 9, right? If the first digit is a 0, well, it's got to go to the next symbol. But if the first digit is a number from 1 to 9, then it's followed by any number of digits that are 0 to 9. So that's looping through here. There's a loop here. Then we get to the next rule here. There's a period possible or not. If there's a period, it's followed by any number of digits from 0 to 9. If there's not, it just flows through. You follow this to the next point. Then you get to the possibility of putting an exponent. So it's either there's no exponent or there's an exponent, which could be preceded by an upper or lowercase e. And that e is then followed by nothing, which would indicate positive, or a positive or negative sign. And that's followed by a sequence of 1 or more digits, 0 to 9. And that would be the syntax for a JSON number. So if you look at this from a path analysis perspective, for example, well, let's look at this. This is definitely a directed graph. We have in it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 enclosed regions. So that implies that there's 11 basis paths. So theoretically, we could look for these basis paths, generate them, maybe use our paths tool to make sure we got the right ones. And once we've got the basis paths, then you basically follow the basis path and you construct a test number with that. So with 11 test cases, you could thoroughly exercise the number parsing in Python. Python. This is for JSON, but this is for me, it's a beautiful way to represent syntax, and it's been around for quite a while. Although, as I see more and more people that have syntax problems, and less people are familiar with using syntax diagrams for test design. So have fun if you have a syntax-related problem, like, for example, parsing an email address. This may be an excellent way to generate a set of test email addresses to exercise your parser. So thank you very much.